In this video, I want to look at the basic antiderivatives for trig functions. To get started, I want to recall that the antiderivative of little f of x dx is equal to capital F of x plus any constant that we want to use if and only if capital F prime is equal to little f of x. And what we're going to do is we're going to look at derivatives of various trig functions and rewrite these properties as integral facts. So to start with, let's look at the derivative of the sine of x. We know that that is the cosine of x. Hence, we can say that the indefinite integral of the cosine is going to be the sine of x plus any constant that we want to add. The derivative of the cosine of x is equal to minus the sine of x. And if I want to actually isolate the sine here, what I'm going to do is I'm going to divide both sides of this particular equation by -1. And when we do, we get that the derivative of minus the cosine of x is going to be positive the sine of x. And that can be rewritten as the integral of the sine of x is equal to minus the cosine of x plus any constant that we want to add. So let's move on to the next pair of trig functions. If I want to look at the derivative of the tangent of x, that is the secant squared of x. So I can rewrite that fact as the integral of secant squared is going to be tangent of x plus any constant that I want to add. The derivative of the cotangent of x is minus the cosecant squared of x. And here again, if I want to isolate a cosecant squared, I need to divide both sides of this equation by -1. And when I do, this equation becomes that the derivative of minus the cotangent of x will be positive cosecant squared of x. And hence, the appropriate integration fact is that the integral of cosecant squared of x can be written as minus the cotangent of x plus any constant that we want to add. Our final two trig functions are the secant and the cosecant, and the derivative of the secant of x is known to be the secant of x times the tangent of x, and so the equivalent integration fact is that the integral of secant of x times tangent of x with respect to x is going to be equal to the secant of x plus any constant that we want to add. And finally, the derivative of the cosecant of x is minus the cosecant of x times, let me get my notation cleaned up. So the derivative of the cosecant of x is minus the cosecant of x times the cotangent of x. And if I divide this particular equation by -1, I get the equation, the derivative of minus cosecant of x will be positive cosecant of x times cotangent of x, and so the equivalent integration fact will be that the integral of cosecant of x times cotangent of x is minus the cosecant of x plus any constant that you want to add.